Okay, so we were talking about this, where we're getting close to being able to represent the database system in what's called the relational model. And the relational model is going to be, in the end, the tables or set of tables that we're going to implement in whatever database development and management system we're going to be using. And so there are certain rules that we need to follow. There's these basic 3 rules that have to do with cardinality. So based on the ER diagram, where we've got our entities and we've got our relationships, and we know the type of relationships and cardinality, we're going to follow these 3 rules. If I've got 2 entities that the relationship is 1-to-1, the only thing I'm going to do is I'm going to grab the primary keys of these and I can put them in the other entity, or I could just join them into one table. I can do either of those things. I can leave them as 2 separate tables and just swap or put the primary keys on each one, or I can join them into one table. If the relationship is 1-to-n, I'm going to grab the primary key to one side and put it on the other side. And the third, the more complicated one, is if I have a relationship that's many to many. In the case of the many to many, I'm going to create a new table from the 2 entities. I'm not going to remove the 2 entities. The 2 entities are going to stay there, but I'm going to create a new table that is going to grab the 2 primary keys of both original tables and merge them. That merging is called a composite key. And from that new table, I'm going to add whatever other attributes I think I might need. Okay, so we're going to follow these 3 rules. And what we're going to do now is let's revisit the social corp example, kind of round it out here. So we already know this. This is the company profile. Remember that your application project, basically when I'm describing here in the social corp, that's what you should be kind of building in your PowerPoints as we move forward through the stages. Okay, so that's the company bio. We already know the company bio. These are the characteristics that we should have extracted through the analysis part. Then from there, we identify the entities and the relationships. For this problem, we only have 4 entities. We identify 6 relationships there. And from the relationships, we identify the cardinality. So we have the different cardinalities for each of the situations. And so there are the entities and the cardinality. Actually, the ER diagram is kind of like a graphical representation of this. We can do the tables from the ER diagram, and we can just use this information actually to create the tables. The ER diagram is just a graphical way to represent this. We also identify the attributes. But notice one thing. Can somebody tell me? We already identified the attributes, right? For each of the entities. But in the end, we have to take this and put it in a format that we're going to implement in the database. We're going to eventually create tables. So we identified the attributes and we identified the primary keys and the weak entities. Can somebody tell me of these attributes that we defined, the way we defined them here? What are we going to need to change of these attributes once we think about the relational model and the implementation? Okay, so right now we define the attributes. So we know that an employee has a social security number, a name, an address, salary, etc. for each of them. And that's the way we define them, like they're written down there. But we've been talking last class about naming attributes. So when we implement this, what are we going to need to modify or change?
You would need to get a specific name for each one. So like in order to be able to pull them out, like instead of searching like for a specific address, A, B, or
Good, Daniel. Miguel, you raise your hand?
Yeah, it was to make the name short, like the attribute to a.
Mnemonic, correct, good job, Miguel and Daniel. So basically that, we've identified the attributes, for example, we know there's a social security number, but we're probably not gonna call in the table, we're probably not gonna call that field or that column social security number. We might say SSN, we're eventually gonna turn these into shorter names and trying to use mnemonics to be able to quickly identify. So right now at this stage, we're just identifying what they are, but we're gonna have to define a nomenclature and a format. And so from that, we get the ER diagram. That's what at this point is where we were at with regards to this example. Now what we want to do is that from this ER diagram and this, basically this table of relationships and cardinality, we want to create the relational model. So the first thing we're going to do, how many entities did we have in this for this problem or situation? No, entities? 4. So by default, there's going to be, or to start off, there's going to be 4 tables. A table for employee, a table for department, a table for project, and a table for dependent. Those are going to be the 4 tables. Okay. Now, let's see now about the relationships. So the first thing is that I'm going to have 4 tables, a table for employee, a table for department, a table for project, and a table for dependent. Notice that there's another table over here, the 5th table. Let's see how where that works. But okay, let's go back to the relationships. What relationships? Let's see each of the relationships. So employee is assigned to departments, and that's a 1-to-n relationship. In the situation where I have a 1-to-n relationship, I'm going to grab the primary key of the entity that's on the one side, and I'm going to put it on the entity that's on the n side. So notice that in the relational model, what's happening here? In the employee table, I've added the department ID. You see that? So there was a 1-to-n or n-to-1 relationship. I'm grabbing the primary key of this one and I'm bringing it over here. Okay. Notice that the primary keys of the table in this nomenclature that I'm using here are underscored and bold. The attributes that I'm adding from other tables, which are going to be the primary keys, are just underscored. And there's a line connecting. Okay. What other relationships do we have here? An employee manages a department. Okay. What did we, and that relationship is 1-to-1. What did we say we were going to do if it was a 1-to-1? Remember, there's just 3 rules. If it was a 1-to-1, what were we going to do? We can join both of them into one table. That's usually not what's done because you're creating a sort of a mashup table. The other thing we can do is that we can just grab the primary keys and put them in each table. So we can do either of those things. In this case, what's done here is that notice that the employee already has the department ID. I already added it because of the 1-to-n. And now I'm adding the social security number. But I'm calling it differently. I'm calling the department manager social security number, but it's still the primary key from the employee, and I'm connected. Okay. By the way, this diagram, the way we're seeing it here, this is literally what we're going to see in Microsoft Access. So when we put all the information in, there is a view in Microsoft Access that's called the relational view, and this is actually what we're going to see. We're going to see the tables, and we're going to see the connections. We need to verify that these are correct. Let's see what else we have. An employee supervises an employee. Right? There's a 1-to-n relationship with itself. This only means that on the employee table, there's going to be the employee, and then there's going to be the employee supervisor social security number. So kind of like having two employee tables, I'm adding the attribute, in this case, to the same one. Let's see which other, an employee. A department manages projects. That's a one-to-N relationship. So that means that the department ID, I should add it to the project table. And we're going to see that that's the case. In the project table, I've added the department ID and I've connected. Okay. I'm going to leave the end to end to sort of yeah. An employee has dependents. That's a one-to-N relationship. And notice that, remember that the dependent was a weak entity because it didn't have an identifier. Well, I created a dependent ID, so it's not a weak entity. And I've added, because it's a one-to-N relationship, I've added this primary key over here and I've connected. Yes, go ahead.
So, based on the relationship that each entity has with each other, we're going to the attributes. Because, for example, in the civil project, you said that each project has a department that is like developing it. So then the department would be an attribute, but it is an entity.
Oh, well, that's a good question. So the department is an entity.
Yeah.
The department ID is the attribute. And that's what we're adding to the project. So the entity is its department, but what is the attribute? The ID of the department. And that's the one that's in the department table. And we need to add it to the project table because of the one-to-one relationship.
Yeah, so when we're doing that with our own company, we have to do the relationship.
ER diagram.
Yeah, the error diagram, and then we could make more attributes.
Oh, yeah, sure. Yeah, yes, of course. This analysis that we did here, this is the design, okay? And the design is going to give you, again, the entities, the attributes you identify at the beginning, and the relationships. When you grab this and turn it into the relational model, some additional things might need to be added, okay? For example, when we implement it in the database system, we can't have weak entities. So we need to add an attribute or something that makes this not deal with that. The relationships themselves, like for example, the end-to-end that I'm going to talk about right here, creates new tables where I can add new attributes. So this is one level, I'm going to say it this way. This is one level of definition of the attributes. Once we go to the relational model, we're going to a second level where we can add attributes. And actually, some of the attributes can be named, even though they're primary keys and they're related. So the department and the employee also have employees related to them. But one is the manager of the department, the other is the supervisor of the employee. So I add these and I can change the names a little bit, as long as I link them to the primary key of the table. Now, let's look at the last relationship. There's a last relationship here that says that the employee works on projects. And remember that that was a many-to-many. So an employee can work on many projects. A project can have many employees working. So that's a many-to-many relationship. So when there's a many-to-many relationship, we're going to grab the primary, we're going to create a new table. We can call that new table however we want. Okay. The name should reflect what we're talking about. This new table for this case, I think it's called employee projects. So the new table, employee projects, is going to grab both primary keys of project and employee. This is going to be a new primary key. It's called a composite key, meaning that to identify anything that has to do with the relationship of employee and project, I need both things, okay? So let's say that, Anna, you are an employee of this company and you're working on 20 projects. I need to know how many hours you've invested in the project, in the application project of this course. So that's one of your main projects. So how am I going to identify that? I need your employee number and I need the number of the project, right? Once I have both of these, I can know how many hours you as an employee have worked on that specific project. Okay, that's why it's a combination of both of these. I need both of them to know that. Right now, I've only added to this new table, going back to the next comment. To this new table, I've only added a new attribute that's employee project hours. But for this new table, I could add other attributes that might be of interest. So I might want to know the project hours that you've invested in the project. I might want to know if you used other resources for the project. So maybe travel resources, etc. I'm going to give you an example of how this works literally. And I love to give examples of my wife work because it's so cool. But, we joke with our daughter because our daughter asks us, what do you do, Dad? And I'm like, I'm a teacher, like your miss, I'm a teacher. And then she, what does mommy do? And I say, mommy makes planes. She makes planes. Yeah, mommy makes planes. Planes don't get made if mommy doesn't do her job. But something that happens in Honeywell and many other companies, by the way, is that my wife has projects where she works. So she has an employee number and she has many projects that she's working. But projects have budgets, and budgets pay for resources, and a person is a resource. So budgets need to be verified with regards to resources. So one thing my wife has to do, and it's always like, oh, I forgot to do this. I need to do it at night, or I need to do it on the weekend. Is that she says, I need to do my e-charge. So what is an e-charge? She has to go in the system in Honeywell and say, okay, for this project, today I logged in 5 hours. And for this other project, I logged in today 4 hours. Why is that important? Because that reflects the work that the employee is doing. And also those hours are charged to the budget of the project. So that's why this relationship of employee and projects is important. And that's why we need to separate it and be able to find information regarding employees and projects separately. If we didn't have this table, it was going to be really confusing to be able to identify how many hours I might be working on a specific project of this course if there wasn't a way to relate to that. And the only way of knowing how much hours you worked on this specific project is knowing who you are and knowing the specific project. So now this creates a new primary key that again is called a composite primary key. And a composite primary key isn't anything else that a primary key that's comprised of more than one attribute. And that might be valid. No, it might be valid. It is valid. This diagram that I'm showing here, this is the relational model. This is what we would grab and we would implement in Microsoft Access or whatever other software we're using. Okay. Questions with this one before I go to the next slide? So the other thing that we need to do is that we need to, the attributes that we define, we need to establish or determine this sort of nomenclature or structure for the names. And so for each of the tables, I'm going to have the attributes or the fields. This is a nomenclature I'm using for this example. So employees are always going to have EMP at the beginning, underscore a shorter text that identifies it. I'm putting in bold and underscore the primary keys. And I'm adding a description, very brief description. For each of the tables, we have that information. Something very important in the lab exercises we're going to be doing, and in your application project, I want to see the complete documentation in Microsoft Office. Right? That means that we're not going to define an attribute and just leave it blank. We want somebody that hasn't developed it to be able to look at it and say, okay, Gen is the gender. Sal is the salary. Okay. We mentioned about the underscore STD. So underscore STD doesn't mean sexually transmitted disease. It means okay, so we need to be able to remember that you asked that. We need to be able to know what we're talking about. Okay, or else we might get confused. So the description, very brief description of each of the attributes or elements in our system, our information system is important. These two things are what we need to be able to implement the database in the software. Well, there's one more thing that's not reflected here, but that's neat when we start implementing or developing, is that for each of these, we need to know what type of data it is. Okay. So there's going to be some things that are going to be numeric, some are going to be alphanumeric, etc. Type of see if I can correct that. There we go. Okay. Yes, there we go. Okay. Questions up to this point? This is where we're going to be getting at with your application projects as well. Okay, so remember the gym fitness exercise you guys did? You had this gymnasium that had memberships. It had sold merchandise. It had passes in past categories, etc. And you guys worked on the basically the ER diagram for this. And you turned that in. Here in the PowerPoint, in the module 3 PowerPoint is the solution to the problem, so you can check. In general, what you guys were doing was correct. There might be a few things that might be different in interpretation, but that's not a problem. I just wanted to add this slide. I added this slide to module 3, module 2. The symbology that we've been using for ER diagrams is the most simple version of the symbology. Boxes and what would these be called? Rumlets? Oh yeah, that's the technical term, or diamonds, whatever. That's a basic symbology that we're using. There's a more complex symbology that you might see in some ER diagrams, or more specific symbology. These are the ones that we already saw: entity, relationship, attribute, multi-value attribute, etc. And in the connections or the cardinality, right now we only put lines, and we wrote down the cardinality in each of the connections. There's actually some symbology that we can use for that to represent each of the situations there. So I'm just putting these here because you might go on the internet and look at ER diagrams, and they might have this symbology. So if I have a circle, it means 0 or 1. That's much more specific. Okay. If it's got this sort of arrow, it means many. If it's got one line, 1. If it's got 2 lines, it's only being a little bit more specific and saying that's 1 and only 1. Okay. Well, why is it 1 and only 1? For example, I could have 0 dependents, right? Or I could have many dependents, right? But if I'm a member of the club, I have a membership, and I have only 1 membership. Okay. 1 and only 1. If I don't have a membership, I'm not a member. So that's 1 and only 1. one membership and one, so that's the difference when it's got two lines. It's got the circle and the arrow, it's zero or many, it's got the line and the arrow, one or many. Okay, so I'm just mentioning this because in the ER diagram, that's the solution for this. They didn't write down the relationships, they only wrote down the symbols. And so I added the cardinality and the minimum and maximum, just to clear that up, because if I didn't give you this, then these might be confusing. And so this is an example of another type of ER diagram. A member is going to pay a membership. Only one member pays one membership, and the membership is of one member. Member buys a one-day pass. The member, that's one to many. I could buy one, or I could buy many, or I could buy none. The one-day pass has a category that's into one. A one-day pass can have only one category, but a category can have many passes can have that category. A member does or buys via a sales transaction. So a member can have many sales transactions, but a sales transaction is only a specific sales transaction is only associated with one member. And through the sales transaction, I can have a lot of merchandise. A sales transaction can have many merchandise, and a merchandise item can be in many sales transactions. By the way, this might be confusing. The way this is being interpreted is that the merchandise items don't have a specific serial number. Okay, what do I mean by this? You're at a gym. What can you buy at a gym? I don't go to gyms because there's exercise in gyms, and I'm kind of allergic to exercise, so I don't know about gyms. I pass in front of gyms. I know what they are and the type of things they have inside, but I try to not go inside them. So for those of you who have been in gyms, what could they sell you at a gym? Water, first, that's a good example. Bottles of water. Monster drinks, energy drinks. So what's happening here is that the transaction, the merchandise is the water bottle. So I can buy many water bottles, right? And a water bottle, so Alejandro could buy 3 water bottles, Arturo could buy 4 water bottles, but each of the water bottles doesn't have a specific, I'm not tracking the specific serial number, I'm just tracking volume. That's why in a sales transaction, I could have a lot of merchandise, and one merchandise item, like the bottle, can appear in many sales transactions. Okay, that's why this is end-to-end. I'm mentioning this because this could have been interpreted a little bit differently, and it's not necessarily incorrect. So you could have said, instead of water bottles, I'm going to be selling you equipment. So I'm going to be selling you, I don't know, what type of equipment could I sell at a gym? A weight. And the weight the weight I'm selling, a hand weight, has a specific serial number. And so that would mean that a sales transaction can have many items, but a specific item is only going to appear in one sales transaction. Okay, that would make this one to end. So meaning that the 2 interpretations could be correct. For this specific case, it's being interpreted this way. Okay, this would be the ER diagram. Okay, this would be the ER diagram for the gym fitness. Okay, questions with this one? I'm putting it here on the slides. You can check it with the ones you guys did. You're probably going to see that from at least from what I saw that you guys were doing, that you guys were probably doing it. We'll probably have some similar things. Maybe there were differences in interpretation here. But again, that's the interpretation. Okay, so what I want you to do is that I want you to work in houses, and you can do that for the rest of the class. You can work on it now. You can start working on it now. You can take a 10-minute break, however you want. Once you turn it in, you may leave and the class for you is over. What I want you to do is based on this and the rules that I just stated, I want you to create the relational model, which is basically extract the tables and do the rules that we just did. Okay? Basically for this, what I want you to do is to create this and this. Okay? Basically these two slides of the Sosa Corp. That's what I want you to do for the gym fitness, based on this. Okay, so you're gonna work in houses. You're gonna turn in one per house. There's gonna be an assignment. Blackboard. You can ask the questions. Once you finish, you're done. Okay, and you can use the 10-minute break or not, as you wish. And we're gonna review the solution on. We're gonna review the solution on Monday. Okay. Questions? Good. This PowerPoint is in Blackboard. You can view it there. I'm gonna put it on the screen again in a moment. Just give me a moment, sure.